What is up, guys? We're going to be taking a look at this lab, CSRF, where token validation depends on token being present. This is a very straightforward CSRF lab. If you've understood the previous two labs in the CSRF series, this shouldn't pose you any problem, although it's worth noting that the code snippet once again does not work for the Burp Suite Community Edition. It's going to require some modification. So we're logged in as the user Wiener. First thing we're going to do is explore the change email functionality. Let's set a new email address and we'll capture the HTTP request with Burp Proxy. So here is a copy of the post request in Burp Repeater. We can see two values in the post request body. We have the new email that we're changing to. We also have the cross-site request forgery token. Now, so long as we don't have access to the victim's cross-site request forgery token, we can't perform a cross-site request forgery attack. So if we change this token value, assuming we don't know the token, and we try and submit a post request to the web app, we get the response invalid CSRF token. So this is what's protecting the user at the moment. There's clearly some validation of that token in place, and we don't know the token value as the attacker. It turns out that the web app only validates the token if we actually provide a token. Assuming no token is provided, the web app doesn't perform any kind of validation. So we're completely bypassing the requirement for a cross-site request forgery token. Just as proof of concept, let's dispatch another request with a modified email parameter. And you can see in the account section, we have indeed changed the email address on the account. Okay, let's copy the code snippet that's provided by Portswigger, and we'll discuss why it won't work in its current form. We'll head to the exploit server. Let's paste in the code snippet. Similar to other cross-site request forgery labs, this is a self-submitting form. It's a post request. The problem is the values that are passed by the form need to be modified. You can see at the moment we simply have a template. The name and value properties have not been filled out. Simple modification required here. The name is going to be email and the value is going to be the value of the email we want to change to. Let's call it victim@victim.net. We also need to grab our lab ID. Let's paste in our lab ID. Let's choose the store option and we can now view the exploit. And what should happen is as soon as we visit the page, the post request is going to be dispatched, which then changes our email to victim@victim.net. Let's click view exploit and see our email address has been successfully changed. So we have proof of concept now. We simply need to change the value of the email address because we've already assigned our account to victim@victim.net. So let's change it to victim2@victim.net. We'll choose store and then we'll choose deliver exploit to victim. And we get the flag. Congratulations, you solved the lab. So hopefully a fairly straightforward lab to understand. There is cross-site request forgery protection in place by means of a token. That token is successfully validated and does prevent cross-site request forgery attacks so long as the token is provided. And that's really the problem here. The bug with the app is that it only validates the token if we provide the token. So effectively, there's no cross-site request forgery protection in place, period, because the token is not even required. I guess one simple takeaway for the hacker is, while we might try different values for the cross-site request forgery token, it's also worth just seeing what happens if we don't provide the token at all and whether the app still tries to validate the token. Alright, that's pretty much it for this lab. Thanks for checking out the content and I'll catch you guys in the next lab.